Hi, welcome. Thanks for joining. Appreciate it. So this is going to be the start of the devlog. Spent the first video explaining what I'm doing, and spent the last video explaining what I already have. So as you can see, I've got Godot open right now. I've got my project here with my ball scene, my paddle scene, and my main scene with the other scenes with the ball and the paddle incorporated. I have my paddle script, so this is all attached to the paddle itself. As you can see, there's a script there. This is my paddle script. What I'm mainly going to be working on, for the most part, is this handle strike method that I created. I'm going to go over it in a little bit more detail, try to explain it better than I did last time, so that you know what I'm trying to work on. So with handle strike, this is going to be doing this is a lot of the foundation of how I'm going to calculate when the ball is supposed to be struck by the paddle and stuff like that. So with the handle strike method, we've got trigger depth, this variable called trigger depth. This is just trying to, this is just taking into account sort of how deep I hold the trigger, and it's going to be really important. We've got a switch statement, figuring out what the current state is of the paddle, and there's three states. There is ready, winding, and striking. So if the state of the paddle is ready, what that means is, let me run it for you quickly. All that means is that the paddle is at the top. So wouldn't be ready, but right now it's ready. So ready is right at the top. We got winding, which means it's currently like sort of winding back. And then we've got striking, which means it's at a certain depth and it pushes out. And that's when I would calculate whether it's hit the ball or not after we add the collision. So how I'm calculating certain things, so we got when it's ready, we check if the trigger depth is beyond the wind threshold. What the wind threshold is a variable that I set to 0.1, and that's just checking if the trigger has been held enough. If the trigger has been held enough, you can see like I'm sort of holding down the trigger with my graphic. Then it's going to decide, okay, it's beyond the wind threshold now, so begin winding. And that's what that's doing. It's checking trigger depth is greater than the wind threshold, so switch to the winding state. Otherwise, don't do anything, just keep at full radius. In the winding state, we've got multiple things happening. So if the trigger depth is less than the wind threshold, that means the player has, oh, what does it mean? Yeah, sorry, I had to just rejig my memory. Okay, so if the trigger depth is greater than or equal to the wind threshold, that means it's beyond the threshold of the trigger to be considered uh, an amount of change where it should change the state. So that means the player has released the trigger. So did they actually wind or not? Otherwise, I'll go into that in a bit more detail right after this. Other than that, if it's not beyond the wind threshold, meaning, so this is winding. If I release, boom, it's a strike, but this is winding. But if I slowly just move the trigger, it's not beyond the wind threshold. So that's when this else block kicks in. It means the trigger's still being held down, so continue winding. So taking the target radius, which is the max radius times by 1 minus the trigger depth. So it's always checking in comparison to the trigger depth, the target radius where it's trying to go. Max step is just delta times wind speed. Wind speed is this variable here, which I've set. So that's just the speed at which I want it to constantly wind. It's going to be a constant speed. Takes those two variables and sets the current radius to it does current radius equals move towards current radius target radius max step. So that's the current radius where I'm trying to get how fast I want it to be, and I've applied all of that to move towards. So I've used move towards because move towards is a method which allows it to be at a constant rate, as opposed to something like lerp angle, which is a much more smoother. It's a type of ease transition. So we got that happening if the trigger's still being held. However, if it's beyond the wind threshold, meaning they've released the trigger, that's when you check for things such as whether they winded or not. Now, whether they winded or not is interesting because what I wanted it to be is, I'm just gonna show you. So for here, if it's a strike, I've put in a print statement. So I wanted it to be so that if the player's playing and they want to actually strike the ball, that they have to commit. I didn't want them to tap and that it's not a strike. If you can see here, these aren't being considered as a strike. But if you actually hold it and then release, you see that it shows that it's a strike. So it doesn't strike, but if you actually commit, therefore it's a strike. So that's what this section is doing, is checking whether it's the current radius is less than max radius minus minimum charge for strike, which is another variable that I've added up here. So that means that they have committed and they've released the trigger and it's beyond that minimum charge for strike. That means it is a strike. So that's where I've got the print statement here. And then you change the state to striking. Else, it's not past the minimum depth for striking. That means just return back to ready. So I've done set the current radius to the max radius, strike state, change to ready. And that's how you can see here, even though that's why it snaps back to the max radius and it's not being considered as a strike, as you can see here. But if you do it properly, there we go, it is a strike. So that's what's happening there. In the striking state, we've got strike step, which is a variable where I'm taking delta times in it by the strike speed, another variable that I've added over here, and that's the speed at which I want the paddle to sort of come outwards when it's striking. And I'm setting current radius as an animation for using move towards, so it's a constant speed and going from current radius to max radius at the speed of strike step. So it's pretty simple. And we got current radius is less than max radius. Okay, so and essentially what this is doing is checking, okay, move towards it. It moves towards it by the strike step speed. Next frame, the radius has changed, but if it's not at the max radius, then it will constantly keep going from current radius to max radius. And once we've hit max radius or gone beyond it, then we know, okay, we've hit ready, change to the ready state. So the next, what I'm gonna try to do right now, so I've got two things I want to try to tweak about this. So I've shown you this, where when it's not, I keep making that mistake. I've shown you this where it's not, I want the player to commit for a strike, but if they haven't committed, it's not a strike, it doesn't count as it. But I don't like the fact that it snaps back instantly. I want it to sort of ease towards I think it will showcase to the user that you've not actually striked yet. This should be a strike, but if this is the case, then what I'm trying to implement is a more ease, similar to lerp angle. I want it to ease towards the max radius if it's not a strike, rather than have the same thing. Because I think in terms of communication to the player, they won't know the difference between this and that. Do you understand? Because right now we can see that as a developer, I can see with the debug statement that I am striking, and that's not a strike. But if a user is just playing this by himself, like this, I can't tell whether I'm striking or not. So I want it to be a clear animation. If you're not striking, ease towards it. I think that would be a good thing to implement. So I'm going to try to do that next. Also, what I want to do, I've got this. Minimum charge for strike. So currently it's set to 45 pixels. That is a direct pixel translation. However, if I decide at any point to change the max radius, or let's say in the future I have abilities where you're able to make the radius bigger or smaller, it will stay at 45 pixels. So if we got this, we got the pivot rotator. Oh, we've got the pivot rotator here, and let's say this is the paddle. So this is the pivot rotator, this is the pad. Let's say the minimum charge for strike is over here. So if you go beyond this, it'll be a strike. So this is what minimum charge for strike is over here. That's minimum charge for strike. That's 45 pixels. Let's say later in the game I decide to add a way to make the radius bigger. So the radius is bigger. However, it would still be 45 rather than be proportionate. So what I want to make it is, instead of a fixed pixel count, I want it to be proportionate. So instead of a pixel count of 45, I'm going to try to implement it in a way where it's a fraction. That way, if instead of being a fixed 45 pixels, it would be like 10%, which would mean that it can scale. The minimum charge for strike actually scales along with the max radius rather than being a fixed point. So I'm going to try to implement both of them next, and then after that I can figure out what I need to do after that. Yes, so I've been working on this, did quite a few changes. So initially what I've been doing, been working on it, trying to figure out, sort of rejig my memory, how everything's working and the different values I've got. So what I worked on, I changed a couple of the fields to make it a little bit more understandable of what they were doing. Aiming dead zone threshold I changed to an export field so that I'd be able to work on it in the inspector and tweak that threshold. Uh, Things like trigger release threshold. So this was originally wind threshold. Didn't exactly explain what it was. Trigger release threshold is more understandable what it's doing. I've also added this thing called minimum strike charge fraction. Before I had a minimum strike charge, it was a normal export field and it was set to 45 pixels, I believe, something like that. So I've replaced that with this called min strike charge fraction 0.3. The 0.3 being a fraction, so 30%. I've exported it. There's something called, and I found out, property for an export field. You could do property hint dot range and put your range in. So 0 is the minimum, 1 is the maximum, and it goes in steps of 0.01. So you can add whatever you want. Essentially, what that does, instead of being a direct export field, let me just build this. For my exports, it's over here, min strike charge fraction. So instead of like typing it down, because it's obviously in a fraction, so you want it to be 0.3 for 30% or 0.1 for 10%, I could like mistakenly, if it's like a field where you set type in 30 for 30% and it will just muck up everything. What this does is allows it to be toggled like a slider basically. So that's good. Didn't know about that earlier. so, so that's good. We've got that. I'll explain later what I'm doing with that. So the first thing I did was I did learn. Let me just show you. So yeah, so right here, before I had if it's not passed, if they've released the trigger and it's not past the minimum depth for striking, go back to ready basically. So it sets it to ready. So it could how do I explain this? What I wanted before you saw, even though it goes back to ready and it's not in a strike state, it would jump to the top, back to the max radius. So I wanted to ease into it. So in the ready state, I've got my code that I had before to check whether to go to the striking state, whether to go to the winding state. But before that, it checks if the current radius is less than the max radius. Then you use lerp to ease back to the max radius. I set the speed to return speed, which is the same speed as my aiming, so it feels more consistent. And because of the way lerp works, essentially, well, I'll actually show you. Let's get rid of this. Lerp works exponentially to slowly move towards the target. So this is the current, and that's the target it's going to. It's trying to get to max radius. And we'll print the current radius. Build this. Is my controller showing? Yeah. Let's run. So at the bottom, just check. We're not looking for strike. So that's a strike. But we're looking for, before it's a strike, it's not gone past the threshold for a strike, so it's supposed to go back. As you can see with the lerp, it's easing towards the top, the max radius. But because I'm printing the current radius, it never actually gets to 150 because it's always trying to ease towards it. I think it works as like exponentially, it goes half the distance, then another half, then another half. It never actually reaches the max radius. So in order to ensure that it's reaching the max radius, I've got this piece of code here. If math ABS current radius less than max radius less than 0.5, what does that mean? So what it means, what ABS is doing is if the difference between the current and the target, so this is figuring out the distance, if it's less than its tolerance, and the 0.5 is the tolerance. So if it's below, if it's less than 0.5, if the difference of current radius to max radius, the difference is less than 0.5 or above 0.5, this will trigger, which means if it's like almost there, which what lerp does, if it's almost there, then just snap back. Before I had this as the if statement. If current radius is greater than, max radius minus 0.5, so just the edge, and it's less than max radius, so if it's within that range, then snap back. It essentially does the same thing, but this is a little bit more explicit and it's shorter. It's letting you know if the current and the target, the difference between the current and the target is within the threshold, then just snap back. With that enabled, I can get rid of this now. Let's see if this works. With that enabled, let's build it. Before you saw, it would never actually get 250. Let's go back. We're not looking for striking, we're just looking for the ease back. There we go. See that it goes and then reaches 150. It always snaps back to the main. So I've incorporated that, and then percentage. Oh yeah, so I let you know about the min strike charge fraction. So it's being used in the winding to check once the trigger depth is beyond the trigger release threshold, check whether. Okay, so this checks have we gone past the top 30%. Yeah, so we've got the min strike charge fraction, as I explained before. So this is 30%. If it goes beyond the top 30% of the paddle sort of wind up, then we can say sorry, no. Once the trigger has been released, this is checking. Okay, so once we've winded and the trigger has been released, we check has the trigger been released. Then we need to check, are we beyond the threshold to be considered as a strike? If so, transition to the striking state. How we check whether we've reached that minimum strike charge. Before it was the exact pixel, I set it to 45. What that meant was, let's open this up, set it to 45 because I got rid of that variable. Oh my goodness. So this is what it was before, and it was fine. It did work. Why is that not working? There we go. So we set it to 45. Worked. Not considered a strike. Not considered a strike, but that's considered a strike. However, let's say in the future I wanted to change the max radius to 300. You can see the radius is much larger. However, in order to be considered a strike, it's the same amount of pixels. It didn't scale exponentially. So it's not 30% now. Let's say it's like 10%. You got So in order to make it scale exponentially, that's why I've included a min strike charge fraction, and in the winding state we check, instead of the exact pixels, we check if it's the fraction. Can get rid of that. So we check, is current state, current radius less than, within that, beyond that 30% basically. And that way, if max radius, I decided in the future I'll add abilities to make the radius larger. That way, it will always be the top 30%, and there's some consistency rather than making the radius larger, and then it's sort of, that threshold doesn't scale. So that's what I've incorporated. Been working on that. So next up, with that done, and explaining it badly, what I'm going to work on is incorporating next is the collision toggling. So the way I want it to work. So the way I want it to work, we've got the player here. We've got the paddle. I know right now that the paddle is straight. I'm trying to, later on I'm going to make it arced. And we got this, right? That's what we got so far. So if the ball is coming, it's the ball, it's coming up. What I want is, I don't want it to be a typical pinball game where it bounces off this, right? I want the player to deliberately choose to hit the ball. So if they're playing this game and the ball comes below and they've just left it on the max radius and they're not actually striking the ball will actually phase through. That's what I'm trying to figure out, and that's why I've set up these state machine to check, well, if it's ready, or if the paddle is in the winding state, that the ball just phases through. That in order for the player to actually hit the ball, they must be wound. So let's say they're like here. The ball comes into this area and then they decide to release. If they release and the ball is within the range, then the ball will fly off in whatever direction. That way, it's almost like a game of tennis. You can't really just stand there and the ball hits you. And I didn't want it to be that way. I wanted everything to be deliberate by the player. And I thought that that's the way I wanted the gameplay to be honest. So that's what I'm going to try to implement. Okay, so I understand not a lot was happening on my screen. But I've just run into an issue. And I was thinking back to what I was talking about here and how my game was working. So the way my game was working before, I've got the paddle. This is a collision shaped 2D object. And we've got the ball as well, which is a collision shaped 2D as well. And that's how it's basically reacting off everything. And the way I was going to make it work was the collision would be disabled at rest. So when the paddle was ready, collision disabled. When the paddle was winding, disabled collision as well. But at strike is when the collision would be enabled. Now, the upsides of that is that all of the physics and stuff are already done for me. So I'd have to do a bunch of maths and things like that. The downside, when I was testing it, and I'm going to show you here, okay, it works, is, hopefully I can see it, you can see there, what happened, the ball phased through. So because I'm doing a bunch of, it's doing physics ticks. If the paddle is moving too fast upwards and the ball is moving too fast downwards, essentially it phases through. Hold on, I'm gonna do that again. So you can see there, boom, hit, 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 and there we go again. That is a major issue. Secondly, I realized when playing this, well, when going over my thing, is that I'm not really, it's not about the ball reacting to this paddle, it's more whether this ball is within this area. So long as it's within the area, it hits. So in a game, I don't know what type of games. Well, in your old school like Doom games, it's typically referred to as hit scan. So you can see my mouse, right? Let's say the mouse is the ball. Hit scan, all it means is there's not an actual bullet traveling through and stuff like that. It just checks whether it's in line of sight. And if the player fires, as long as it's in line of sight, then it's a hit. So it's not a real bullet. That's for first person shooter game. So my game is a similar concept actually. It's not actually checking like the movement of this paddle and like striking it and then the ball strikes it. It's actually just checking, okay, is it within this sort of cone area? If it is, then have the ball react. Now, the downsides of that is, sorry about that. So the downsides of that is I'm gonna have to do a bunch of physics myself, pull in the ball, so information about the ball in my paddle script, try to work out is it within this vision cone, not vision cone, but is it within the paddle cone once I strike, and if it is, then I'm guessing I'd have to translate that into the ball and work out the physics myself out of that. But that's better, that's more accurate as to what I want rather than the physics, because what I can't have in the game is this scenario where it's moving so fast where it doesn't know what to do and it just phases completely through, and that's not going to be conducive to the game. So I'm going to have to rework things. This happens in programming and development. But yeah, so I'm going to start by reworking it. I'm going to try to import the ball here somehow and work things out. I don't think I'm going to have to rip out everything, but definitely going to have to work on this. So that's good. I'm going to have to course correct, but I just wanted to make sure. So I know you saw not a lot was happening on my screen because I was doing a bunch of research and I was realizing something's gone wrong here. And conceptually, the foundations of what I built is all built on the internal physics, and that's not what I'm looking for. So I'm going to transition into that. Okay, so went away, researched a lot, um, had a break, ate some food, whatever. But yeah, so was just developing and searching for stuff and asking Claude for some help and whatnot. So this is what I come up with. I like what I've done. So actually, firstly, I can get rid of this min strike range. Do I ever use that? Quickly, let me just check. Okay, I don't use that. We'll leave that for now. So basically, what I've done. Where's it gone? We've created this function or method called try strike ball. This is going to get called either inside of striking or inside of the winding state when we're checking for handle strike. And essentially what we've done, we're checking, first we have to check the distance and then we have to check the angle because the angle could be different and then the distance. So first we have a vector 2 that is pivot to ball. You take the ball's global position and then negate that with the pivot rotator's global position. You get like an XY coordinate. You get an XY coordinate. Essentially, you get a vector. And then you can measure that difference. So how it works. Sorry, let me turn that off. So how it works. Let's get rid of this. This is the playing field. You got the pivot rotator here. You got the angle here. Let's say this is the ball. And what I'm getting is that right here. And with the distance is if you just take that vector and you get pivot to ball dot length, you get the length of that. Ooh. You get the length of this here. So with that, what we can calculate is the ball out of distance or is the ball below the pivot rotator? So if the distance is greater than the max radius, so essentially, I'm explaining this badly. You've got the pivot rotator and you've got the max radius. So the pivot rotator, obviously the max radius we've set already up here. Max radius 150. So if it's beyond that, if it's beyond the max radius, then return false. This method returns a boolean. So it returns false if it's beyond the max radius. So if the length is here and that's beyond 150, let's say that's 175, then that's beyond. But if the ball's here, that's less than 150, so it will be within its range, within its length. And also what I've set is to check for that, or if the ball's Y position is greater than the pivot rotator's Y position. So we check since if the ball goes beyond this line, if it goes below it, then it's obviously out of bounds. So it's checking if it's below here, no matter what. Trigger false as well. So we've done that. That's sorts out the distance. Then we got to sort out the angle. This is where a lot of maths got involved, and I'm not really good with maths, so I took a lot of it from Claude. I tried to understand it as much as I could. So the angles, because it's a bit difficult, since within the game you can use the analog stick to angle the paddle anywhere you want. What I've done is you get the ball angle. So this is the angle between the angle of the vector between the pivot and the ball. So it takes this sort of angle here. I'm guessing this sort of angle. it takes the paddle facing angle, so whichever angle the paddle is facing. And so I could be, this is the angle of that, this is the angle of the paddle, assuming that I've just left it up. So then we're trying to calculate, is it within this range? This is a bad drawing, but is it within the range of the between the middle of the paddle and the edge of the angle of how like wide I've made it. I'm explaining this really badly, but it's a lot of maths to this. So angle difference, you call angle difference, so the difference in the angle between the paddle facing angle, whichever angle the paddle's facing, and the ball angle. So the angle of where the pivot is to the ball. And half wedge radians, since from my understanding, under the hood it deals with angles in radians, but obviously for humans it's better for degrees. So we set it to degrees here as an export field, how wide we want that cone. I set it to 90. And since you want it on both sides, you want it sort of in the middle rather than just it starts here and that's 90. You'd rather it halfway between. So what we've got, degrees to radian, strike wedge angle, which I've set to 90, divide that by 2, and that's the half wedge radian. And this checks, this is just the angle difference that we've calculated here. What is the difference between the angle of the ball to the pivot and the direction that the paddle's facing, and seeing it, is that greater than the half wedge radian. So I've set it to 90, so that will be 45. So it'd be here, basically. So it's checking, okay, this whole thing is 90 degrees. So we want half that, which is 45. So is it within 45 positive or 45 negative as well? It could be negative. And that's why we've used ABS. Because I believe ABS is either positive or negative. And yeah, so if that angle is greater, if the ball's angle is greater, then return false. So you return false if it's beyond the distance or below the Y of where the pivot is. Return false. Return false if it's outside of the angle, and then return true if both those don't trigger. So then that way, within my handle strike method, before, where have I put it? In the binding state, when we check, okay, trigger depth is better than the less than the threshold, and basically if we've done a strike motion, then try to strike the ball. If it returns true, then print strike, and if it doesn't, then print that it's not a strike. And I've been testing it. So for the ball, for now, I have actually frozen it inside the inspector, as you can see here. So all that does is it says here, gravity and forces are not applied anymore, because I just want to test it out. So we build that, and I could show you. So if you see here, it's still above the pivot rotator, and it's within the angle. So this should strike true. So you should see it here. If I strike, boom, it's a strike. If I decide to angle it, it should still trigger actually. Oh, that's not a strike, so I'm guessing that's outside the angle. But if you slightly put it in, over here, strike. So this is a strike. If I move it, not a strike. If I go here, not a strike. If I go inside, strike. And we can move this ball about, test it around. If I put it like right on the edge, so it's still inside. I'm gonna make this window smaller, but I don't know how. So if you strike here, should be a strike. Is my controller? Yeah, okay. If we move out the range, not a strike. inside strike. If we move it, rotate it this way, it shouldn't be a strike. Okay, that is odd. How wide have I made that? I'm guessing I've not. I'm guessing my. Let's double check this. How wide is this? Is there a way to check how wide this is? Okay, so since it's a bit difficult because firstly this isn't curved. We've got the pivot rotator here, and obviously I've got a max radius and it'd be a circle. So since it's not curved on the circumference, it's really difficult to test. And also I don't even know where the 90 degrees ends. So this might not even be very accurate. But for now, for now I'm sure it works because if let's say I take the ball outside of this range and we play it, this shouldn't be a strike because it's outside the radius anyways. So it doesn't matter about the angle. Yeah, not strike. So it doesn't matter what I do really here. Doesn't matter if I move it. It's not a strike. As long as I put it right on it. Boom. There. Then it's a strike. If I go here, not a strike. So again, I'm not sure where it stops the angle, the 90-degree angle. So I'm going to try to do that next. So that for debugging it's better. But look, so that's what I've implemented today. It's almost 10 o'clock. I know it's slow progress, but it's still something. Happy with what I did. Hopefully I can wake up tomorrow and do some more. So just to go over, to recap what I've done today. I did format my top of the file variables and stuff so that it's easier to read. So I've put my state machine here. I've commented everything, the tuning values, node references, whatever. Nope, let's not do that. I also, what else did I do? I wrote it down. Okay, yeah, that's what I did. So I introduced lerp. Essentially, everything that we done today was inside handle strike. We introduced lerp for when it's not, the paddle's not been deep enough to trigger a strike and you want to ease it back. I've introduced that. I did also make sure to make sure with lerp. Oh my god. So we've got lerp, which eases the transition between a winding not strike to back to the ready state so that there's an animation. And that last little bit, since with lerp it never actually fully reaches the max radius, the last part you gotta just set it yourself so it snaps back. We've done that. We've added these export property hints, which is something I learnt today, where instead of having a value you put in like an integer value, you can instead have a slider inside the inspector, like so. Is it on the pivot rotator? There we go. So these sliders here, you can see. Set that back. We've done that. What else have we done? Oh yeah, so the other thing we've done, we've incorporated this here, the minimum strike charge fraction. We incorporated it as part of the winding state. And what that does is make sure that the depth needed to trigger a strike is proportionate no matter how big I decide to make the max radius. So that's good. And then also finally, which took up most of my time, I realized that initially I was doing everything in terms of the detecting whether the ball has hit the paddle in a strike state. That was all done through collision. But since there was the paddle and the ball were moving at high speeds, they'd essentially phase through each other. So the best way to do it was a hit scan, and what I've done is what I just explained, is I've introduced a method which returns a boolean called try strike ball, and it manually checks is the ball within the cone, so that instead of relying on internal collision, which depending on how fast things move, things could move phase past each other. So instead of doing that, checked I've tried to capture where the ball is compared to the pivot. How far is it in terms of distance, and what's the angle of it in terms of its angle compared to the angle cone that I'm trying to detect the ball inside, and figuring that out and implementing it. I've all I've done is implemented a print statement. So for next, so I'm done for today. Next time, what we're gonna do is actually try to do something with that. Try to figure out, yeah, so try to do something with that. Instead of just printing something, actually do some calculations. Try to get the ball to actually react instead of just staying just instead of just staying stationary. Thank you. Appreciate it. Take care.